Hi guys, today I welcome you all on this presentation on analyzing the impact of car features on price and profitability. I have been provided this project by Trinity and I would like to share the presentation on my findings on this data. And I have completed all the tasks given to me regarding this data set, and I will be presenting all the tasks and my findings as well as insights in this presentation. So I would like to start this presentation. Our first slides. This is the project description. The project description is like we will be formulating a problem statement in this. The description for the project is as follows, and analyzing the data set and provide insights on how can a car manufacturer optimize pricing and product development decisions to maximize profitability while meeting consumer demands. In short, I would like to explain this point. We have been given a task to find out the features which affect the car's pricing and the profitability of the manufacturer. Predicting the price of a car based on its features and market category. So I have created a logistic regression model in this project, which will be giving me the features which affect the price of the car. The approach which I followed in this presentation. First of all, I formulated a problem statement. The problem statement goes as follows: predicting the price of car based on its features and market category to identify which features are most popular among consumers and how they affect a car's price. For this, the first step was to understand the data. So I spent a lot of time in understanding the data set provided to me with the help of the data dictionary provided. Then initial data analysis was conducted, and after that, before EDA was done, cleaning of data was performed. Text stacks used in this project. I used as my text stacks as MS Excel as well as Python Jupyter Notebook. And some of the libraries like Pandas, NumPy, Matplotlib, Seaborn, these are the libraries I used in the Python Jupyter Notebook. And for the model creation, I used sklearn and stats model. I will be discussing these details in my coming presentation. So understanding the data and initial analysis of the data. This data set which was provided to us contains different features of cars along with their make and model and price of the car, which the target variable in this case is the price of the car. Our raw data set contained 11,914 rows and 16 columns. Target column MSRP, which is also called the price of the car. So first of all, the cleaning of the data set was performed. This whole cleaning was done in Python Jupyter Notebook. For the cleaning part, first of all, missing value treatment was done. Column market category contained 31% missing value. Since this is a very important column, therefore I did not consider to drop this column, but I imputed this column with the mode of it, this column only. Column engine HP contained 69 missing values. These were imputed by the median of the column because this is a numeric column. Similarly, engine cylinders, engine fuel type, number of doors, these columns contain few missing values which were imputed by their mode or median based on the data type of the column. Next comes our duplicate value treatment. Our data set contains 715 duplicate values which were dropped. Outlier treatment. Some of the numerical columns contained outliers, so they were capped with the help of upper bound and lower bound. So I will be moving on to my Jupyter notebook, which where I will be presenting you how the data cleaning part was done. So here is our data set and all this numerical all the data set cleaning was done over here in this Jupyter notebook. So this is my Jupyter notebook. Here the required libraries have been installed. In the line 2, I am reading the data. After that, some initial data analysis has been performed by me. Here comes the data cleaning. Here missing value treatment and outlier treatment as well as duplication dropping of the duplicate columns rows was done. Here are the box plots which were plotted for the numerical columns, which show there are outliers present in the numerical columns. These outliers were kept with the help of this formula. Upper bound and lower bound values are used to cap the values. So as you can see, the outliers are gone after the missing outlier treatment. Now coming on to the visualization part. Visualization was also done in the Python Jupyter notebook. This is a pair plot which was created by me to find out the relationship between different columns. So the insights which I found out with the help of this pair plot is engine HP shows a linear relationship with MSRP, which is our price. So engine HP shows a linear relationship with price, which is also our assumption, first and foremost assumption for the creation of our linear regression model. So the prices of the cars have increased over the years, which is quite true. Higher the engine horsepower, higher is the price, which is quite natural also. So this visualization was also done in Python Jupyter notebook. I'll be showing this in the next slide. So along with the visualization part, I have created the box plots of categorical columns varying with different prices. So on the y-axis, I have plotted the price. On the x-axis, different categorical columns are plotted. So this gives us the some of the insights of these columns are, these plots are cars with engine fuel type as premium unleaded required are most expensive. Cars with engine fuel are regular unleaded are the cheapest car. Coming on to our next plot, this gives us the visualization like cars with transmission type automated manual are expensive. Manual transmission cars are the cheapest, which is quite natural also. All-wheel drive cars are a bit expensive other than other driven type wheel. Price of three-door car is the lowest. Compact cars are lower in prices as compared to mid-size and large cars. Convertible cars are the most expensive, followed by coupe. Next slide. Higher the number of engine cylinders, higher is the price of the car. So I'll be showing you my Jupyter notebook where all this data visualization plots were created. This is our pair plot, which was mentioned in the presentation also. And here is the code for the box plot, which was plotted for the categorical column with the price on y-axis. So these are our box plots. These were created with the help of a for loop. So coming on to our first task, the first task is as follows. How does the popularity of a car model vary across different market categories? To perform this task, I created a pivot table with market category in the rows and counted the number of car models in each category and sorted based on number of models in descending order. Then I calculated the average popularity for each market category. Then I created a stacked column chart visualizing the number of models and average popularity for each market category. The chart is shown in next coming slide. Here is our chart. So as we can see from this chart, we can clearly see that crossover category has the highest number of model counts. Flex fuel cars are leading in terms of popularity. Exotic luxury cars are the least popular. Here comes our second task. What is the relationship between a car's engine and its price? For this, I created a scatter plot in a new worksheet. While selecting the data for my empty scatter plot, I selected column engine HP and MSRP for X and Y axis respectively. The scatter plot is shown in the next slide. Here is a scatter plot which also shows the line of trend and also the equation for the line. So this is there is a linear relationship between engine power and price. The price increases as the engine power increases. Cars with higher engine horsepower are costly. Coming on to our third task, which car features are most important in determining a car's price? So this is our linear regression task. For this task, what I use the Jupyter notebook, and for this, first of all, the pre-preparation of the data, which was performed by me before creating the model. This in pre-preparation includes binary classification of binary categorical variables, dummy variable creation for other categorical variables which have more than two levels, and with the this was done with the help of getDummies function of Python pandas library. Dataset was then split into train and test dataset. Scaling of numerical columns was performed with the help of min-max scaler of sklearn library. Initial 35 features were selected with the help of RFE, that is recursive feature elimination, using scikit-learn library. After creating the different linear regression models using stats model library, our model number 14 was finalized with 22 independent features, all having p-value of less than 0.05 and variance inflation factor less than 5. Then we plotted the error terms. They show the normal distribution with mean equal to 0. Hence, our assumption for linear regression holds true. Our error terms were also independent of each other, which also leads to the trueness of our second assumption of linear regression. Error terms have constant variance, therefore our assumption for linear regression stands valid. So coming on to our Jupyter notebook, which will show us how our model was created. This is our data preparation model. In this, some of the columns which were not required for the model creation were dropped. Here we have created the dummy variables for categorical variables. Here I have splitted the data into test and trained data set into 70-30 part. Rescaling of numerical features were done with the help of min-max scaler. So Y-train and X-train, like Y-train is our dependent variable and X-train contains our independent features. Here we have performed RFE, recursive feature elimination, with the 35 features initially, which gave us first 35 features, which were supported by RFE, and then we started creating our models. So one by one, we have created 14 models, and one by one, I have dropped the columns which was features which were having higher p values or higher VIF values. So after iterating through these models, I have found out this 14th model with where all the which is having like 22 independent features, all having p values less than 0.05 and VIF, that is variance inflation factor, less than 5. So I finalized this model and predicted the value of cars, like predicted the price column with the help of this model. So this is a residual analysis was done after creating the model, which also helped us in confirming the assumptions of our linear regression model. Finally, to complete my task, after predicting the values of y, and here it is r squared value which was found out, and here are the findings of our model. Here are the coefficient values for different independent features, and here we go with the equation of the best fit line, which was found out by us with the help of that linear regression model. So these are our r squared values and adjusted r squared values, which shows that our model is very well generalized on the test data set. So after that, in the last, I created a bar chart which shows the importance of every feature based on its coefficient. So coming on to our presentation now. Here is our, with the help of our model, we were able to get the equation for our line of best fit. Here is our line of best fit. And now I created a bar chart which contains the which shows us the coefficient values for each variable to visualize their relative importance. Here we go. The insights for this plot are: engine HP has the highest coefficient value, hence we can say this is the important feature in our this is the most important feature in predicting the price of the car. This is followed by market category, exotic performance, and highway MPG in terms of importance of features. So this plot shows us the importance of features with the help of their coefficient values. Our next task is as follows. How does the average price of a car vary across different manufacturers? For this task, I created a pivot table which shows the average price of a car for each manufacturer. Then I created a bar chart that visualizes the relationship between manufacturer and average price. Here we go. After visualizing the chart, I can say that to our right is a list of makers who make the most expensive cars like Rolls-Royce, Maybach, Ferrari, etc. Plymouth, Oldsmobile, Suzuki, Pontiac are the makers who make the cheapest cars. Our next task. What is the relationship between fuel efficiency and number of cylinders in a car's engine? Created a scatter plot with number of cylinders on x-axis and highway MPG on the y-axis. Then calculated the correlation coefficient between these two columns with the help of Corel function in MS Excel. Here is our plot. By looking at this scatter plot and the correlation coefficient, it is clearly seen that there is a negative correlation between number of cylinders and fuel efficiency. As the number of cylinders increase in a car, its fuel efficiency reduces linearly, which can be also be confirmed with the help of this correlation coefficient. So now coming on to our Excel sheet, which also contains our dashboard tasks. So I was given 5 different tasks to create, which were then used to create this interactive dashboard in MS Excel. So I was given a few tasks to get the plots done. The plots were created with the help of pivot charts. Here are the pivot charts like model category. These are the plots which were there in the presentation also. So these are the charts which were created by me with the help of pivot charts, answering the questions asked in my dashboard task. So coming on to our dashboard, here is our dashboard. Our first plot shows the distribution of price with brand and body style. This is the total price which was plotted against brand and body style. Again, the average price was also plotted against brand and body style. Our next task was to plot the price versus transmission type and body style. Here is the average price plotted against transmission type and with different body styles. Again, I plotted a line chart against MPG with year and body style. So this is a line chart which is describing different year and average highway MPG, like fuel efficiency, average of fuel efficiency against different body styles. At last, I created this bubble chart. This bubble chart was created, which contains engine HP and highway MPG price. Like the bubbles are the size of the bubbles is determined with the help of price, and on an R axis I have engine HP and highway MPG. So coming on to the interaction level of our dashboard, this is a highly interactive dashboard which was created by me. So I can these are the slicers which were placed to help the stakeholders so that they can easily identify and easily filter out the charts based on their requirement. I will be filtering out some of the features over here, like to find out the detail, and then I create after inserting these slicers, I connected these slicers with the pivot tables with the each and every pivot table out of which these charts were created. So when I select diesel, the details of all the diesel cars come into the chart. Also, I will be selecting electric. With the help of control, I will be selecting electric. So I selected first 3 levels of the category engine fuel type. So this will show us the diesel, electric, and fuel flex premium data cars. So I will be clearing this filter. Here is our year filter, with the help of which we can get the data for each and every year. Like this data contains years from 2000 timeline of 2017, starting from 1990. So if we want to get the data of 1996, we need to simply click on the 1996. I will be clearing this filter also. Now, next coming on to vehicle style, make and transmission type. If I click on automatic and manual transmission type, I'll be getting the data of that particular transmission type. If now I've selected the automatic transmission type, I have been provided with the data. The plots show me the data for automatic transmission type. So this is how our interactive dashboard with the help of slicers was created. So coming on to the results and finding of these this project. The project helped me gain a good hands-on experience. The case study also helped me improve my data visualization skills. Project has taught me how to create an interactive dashboard in Excel, which was a bit challenging for me, but I enjoyed doing that. It also helped me increase my presentation skills. Now I feel much more comfortable and confident in data analytics and visualization. So by this, we come to the end of our presentation. I thank all my stakeholders for giving me the chance to present my skills, data analysis skills to all of you. I will be concluding this presentation now. Thank you. Thank you very much.